All right, this series problem is from an unknown year, and that's okay. It's another fairly straightforward problem that we use to get you just thinking about tailors and putting them together. Other problems might give you the more recent feel for the tailors and how they test them. So once again, you're given a starting point and then 3 derivatives. This tailor is centered at 1, and the first question says write the third degree Taylor polynomial. So we start with our given starting point of 3. And then we have our first derivative times x minus 1 to the first over 1 factorial. Then we have our second derivative of 4 times x minus 1 squared over 2 factorial, which is just 2. And then we have the third derivative, a negative 2, x minus 1 cubed over 3 factorial. And I'm going to go ahead and clean this up to get 3 minus an x minus 1 plus 4 over 2 is 2, x minus 1 squared, and then 2 over 6 is going to give us just a 1/3, so minus x minus 1 cubed over 3. So that is my third degree Taylor, and I use it to approximate 1.1. So f of 1.1 is approximately 3 minus 1.1 minus 1 plus 2 times 1.1 minus 1 squared minus 1.1 minus 1 cubed over 3, and I'm not going to do any more work there. Okay, so now they want us to write the second degree Taylor for f prime. So that means take what we had for f as a third degree and differentiate it term by term. So I'll be left with negative 1 plus 4 times x minus 1. By the way, the negative 1 comes from differentiating the second term. First term went to 0. Third term, I bring down the 2 and drop a degree, so I get 4 times x minus 1. The final term, if I bring down the 3, it cancels with this 3, and I'm left with a negative x minus 1 squared. So to approximate f prime of 1.1, I'm just going to plug in 1.1 into each of these terms. And let's see, it's 1.1. I need 1.1 minus 1, and then minus 1.1 minus 1 squared. Okay, the next question says write me the fourth degree for g, which is the antiderivative of f. So I come back to my third degree term, my third degree Taylor polynomial for f, and I need to integrate it term by term. And I'm going to put in a plus c at the beginning, and then 3 goes to 3x, and then my x minus 1 goes to x minus 1 squared over 2. My next term goes to 2 divided by 3, x minus 1 cubed, and my final term goes to x minus 1 to the 4th now over 12. And in terms of this c value, I know that if I plug 1 in for g, I'm integrating no area, I'm accumulating no area because I'm integrating from 1 to 1. So if I plug in 1 for all of these x terms, I should get out a 0. So if I do that, these last 3 terms all go to 0. So I'm left with c plus 3 equals 0, which means that c has to be negative 3. And so I'm going to go ahead and write that in here. This is my final answer is negative 3 plus 3x minus x minus 1 squared over 2 plus 2/3 x minus 1 cubed minus x minus 1 to the 4th over 12. So that is your answer for C. For D, it asks, can you determine f of 2 from the information given? It's basically saying, can you approximate f of 2? And that would have to go way back up to part A where we had f of x approximated. And the real question is 2 within the interval of convergence for this series? Well, I don't know that we even know what the series is. We know parts of the series, but we don't have a pattern here for what the derivative is, so I can't really do a ratio test to determine the interval of convergence here. I have no idea what the interval of convergence is. So having said that, if I can't actually figure out the radius of convergence, then I don't know if 2 can be determined from the information given. I know that 2 is a full point away from 1, so I'm feeling like maybe, maybe not. I don't know. So I'm not so sure that this is even a valid question because we don't have the information. And so the answer is, are you going to love this? IDK. I have no idea. So I'm not sure that that's actually a really valid question, so we're going to take a pass on it.